So now we discuss about the atomic models. So after the discovery of electrons which are negatively charged, and after the discovery of protons which are positively charged, in atom, the many scientists tried to explain the arrangement, nothing but to explain this distribution of electrons and protons within the atom. So now everyone knows that electrons and protons are present within the atom, but what is their position, how they are distributed over the atom was unknown. To explain the position, nothing but distribution of this positive charged and negatively charged particles, many scientists given their atomic models. At first, the first model was given by J.J. Thompson. He is known as Thompson's atomic model. So itself the name tells that it was proposed by J.J. Thompson. So according to this model, an atom is in spherical shape, in which the total positive charge is distributed uniformly all over the atom. Means the total positive charge distributed all over the sphere. Now what about the electrons which are with negative charge? They are embedded, they are fixed in a particular positions to maintain the electrostatic forces. Means the electrons are embedded, the electrons are fixed in such position to maintain the neutrality. At a position lo unte they can maintain the neutrality in the atom. And the electrons negative charge, protons positive charge, nothing but total is positive charge, electron negative charge. So balance a model lo the electrons are fixed. So this model is compared with watermelon, in which the total red color mass is compared with the positive charge. The seeds present in it are compared with the electrons. It is also treated as a plum pudding model, or apple pudding model, or a raisin pudding model. Means the raisins or apples or plums are fixed in a particular places. That's why it is called watermelon model or any plum pudding, apple pudding, raisin pudding models. So it was the first theory, that's why there is some importance given to the J.J. Thompson's atomic model. But only the correct point in this theory we can observe, that is atom is spherically shaped. Remaining all points are looking totally wrong assumptions. And this theory totally loses its identity after alpha rays scattering Alpha rays scattering experiment. Alpha ray scattering experiment of Rutherford. Okay, this was the J.J. Thompson's atomic model, so which was treated as a first atomic model. As it has many drawbacks. There is a perfect point is only that atom is spherically shaped. And the one thing is, the time when Thompson given his atomic model, there is no discovery of neutrons. So there is no matter about the neutrons. So now we see the Rutherford's atomic model. So this atomic model is totally based on his experiment. This theory, this Rutherford atomic model totally based on his experiment, which is known as alpha rays scattering experiment. So now we discuss about the experiment. So now we discuss the alpha ray scattering experiment. Okay, so in this experiment, he passed the alpha rays. So how you got the alpha rays means with the help of this is alpha rays, the source of alpha rays. From this chamber, he was able to produce the alpha rays by using an element radium or any. And as for they are passed through a split, generally lead split, just for the straight direction, and they are passed over a gold foil. They are just passed over a gold foil, a very thin, nearly 100 nanometer thin gold foil. And we know that alpha rays are invisible. So when they pass over the gold foil, they are scattered. But how he observed the scattering? So it is possible to him by using a circular shaped fluorescent screen. We know that fluorescent material name, it is a zinc sulfide screen. Zinc sulfide is a fluorescent material. The fluorescent material means if any ray, alpha ray, beta ray, gamma ray, X rays, if any rays or cathode rays strike on that screen, there is a formation of a bright spot. That is called scintillations. So to observe the position of alpha rays after scattering, he arranged a circular shaped zinc sulfide screen. And in the experiment, So this was the experiment. The alpha rays were passed over the thin gold foil, and the alpha rays after passing through the alpha, the atoms of gold foil, they are just scattered into different directions. The different directions can be observed with help of bright spots formed on the circular shaped zinc sulfide screen. So this is the experiment done by the Rutherford. It is called Rutherford's alpha ray scattering experiment. And after what are the observations? What are the observations in this experiment? The observation done by Rutherford. So the observations done by the Rutherford in his experiment are: most of the alpha rays easily passed through the foil. Maximum total nearly approximately 99% of the alpha particles, nothing but alpha rays, simply passed through the gold foil, nothing but atoms of gold. Next, very few particles, nothing but very few rays are deflected with some angle. So maximum alpha rays are not at all deflected. They simply passed through the gold atoms of that foil, and very few particles are deflected with some angle. And he also observed that very few, nothing but negligible number, that is just 1 in 20,000 particles. And 20,000 particles, just one particle, it is totally bounced back. Totally bounced back means exactly 180 degrees slow, totally back side వచ్చేసింది. So what are the observations? The most of the alpha rays are passed through the foil. Passed through the foil means they are nothing but passed through the gold atoms, and very few particles are deflected with some angle. Next are very few particles, that is 1 in 20,000, are totally bounced back. అంటే 20,000 approximately 20,000 particles దాంట్లోంచి మూవ్ అయితే one particle exactly bounced back అయిపోయింది. That is simply called 180 degrees to deflect angle. So these are the observations made by Rutherford. So after looking these observations, he was able to give his atomic model. We can say the Rutherford atomic model is nothing but the result of alpha rays scattering experiment. Now we see the main postulates of Rutherford's atomic model. Okay. So what are the main postulates of Rutherford? So we give these postulates by comparing with his observations of that experiment. So the first one, most of the space in the atom is vacant. Nothing but most of the space in the atom is vacant or empty. So how he concluded this point means for example, if you take as a gold atom, most of the particles simply pass through the atom. So we must remember that the charge of alpha particles is +2 charge. Means alpha particles are positively charged. So the positively charged particles simply pass through the atom. So he concluded that the most of the space in the atom is empty place. So empty place kabatti the most of the alpha rays are nothing but alpha particles are simply passed out through the atom. And in his observation he noticed that some are deflected with some angle. And very few are deflected, bounce back. So with this observation, he concluded that the alpha particles, some are deflected because they are near to the positive charge. Because alpha particles are positively charged, they are deflected means there is some other positive charge is there, that's why there is a repulsion force is formed. That's why they are deflected. And the particles which are exactly passed through that positive charge are bounced back. So with these observations, he concluded that the total positive charge is concentrated at the central point. At the center point of atom, which is known as nucleus. So this is the very best thing, this is the very good thing in the Rutherford atomic model. Before the Rutherford atomic model, there is no presence of nucleus term. There is no presence of nucleus concept. Nucleus concept, positive charge atom middle part lo untadi. The total positive charge is concentrated at the center of the atom, which is treated as nucleus. This was at first time introduced by Rutherford in his atomic model. Next. So what about the electrons? He given that electrons revolve around the nucleus. Revolve around the nucleus in a circular orbit. In a circular orbit with various distances, and he compared that electrons with planets and the nucleus with sun. Just like the planets revolve around the sun, the electrons are also revolve around the nucleus. The circular orbits, nothing but the circular paths, are called orbits. Here another important one is the revolving of electrons must be very speed. He also said that electrons moves with very high speed. So why he used the high speed of electrons? Because to maintain the neutrality, to maintain the stability, the electrons are revolve around the nucleus with very high speed. Why he mentioned the high speed means to maintain the neutrality of atoms and for the stability of atoms. He said that electrons revolve around the nucleus with very high speed. So very high speed to move to why they mentioned high speed means if they are in low speed, there is a possibility of Coulombic attraction force between this negatively charged electron and the positively charged nucleus. So positively charged nucleus ki electron ki attraction aye chance untadi kabatti they may combine together. After that the collapsing of atom takes place. To overcome that problem, he said that the high speed of electrons, due to the high speed of electrons, and there is also one other point is that due to the high speed, there is a possibility of centrifugal forces of electrons. Centrifugal forces of electrons. So this centrifugal of electron forces makes the electron come out from the atom. And the centrifugal forces of electrons electron akkada circular orbit nunchi bayatiki vache chance undi. But he said that there is also Coulombic attraction present which is exactly compensated. Coulombic attraction means this is called centripetal force. The Coulombic attraction is towards the inside the atom. The centrifugal forces are outside the atom. He said that electrons moves with high speed around the nucleus, and in the atom the Coulombic forces are exactly balanced. The Coulombic forces of this negative positive charged species are exactly compensate the centrifugal forces of electron. So that's why electrons are simply and stably moves around the nucleus. So this is totally according to Rutherford. Okay. Means this atomic model compared with solar system, and it is also called planetary model of atom. So these are the main assumptions, main postulates of Rutherford's atomic theory, which is totally based on his alpha rays scattering experiment. But there is many drawbacks are present. Now we see about the drawbacks of Rutherford atomic model. For any theory, it is important to know the limitations or nothing but failures of the theory. Limitations, sorry, but you can say drawbacks. So what are the main drawbacks in it is it could not explain the stability of atoms. But just now we discussed according to the Rutherford theory, the Coulombic attractions and centrifugal attractions are compensated with each other and become stable. But according to electromagnetic theory, But according to electromagnetic theory, any charged body like electrons moves with very high speed. It loses its energy continuously. అంటే ఎలక్ట్రాన్ లాంటి చార్జ్డ్ బాడీ, ఎలక్ట్రాన్ లాంటి చార్జ్డ్ పార్టికల్స్ ఇలా హై స్పీడ్తో మూవ్ అయింది అనుకోండి, ఇట్ లూజెస్, అకార్డింగ్ టు దిస్ ఎలక్ట్రోమాగ్నెటిక్ థియరీ, ఇట్ లూజెస్ ఇట్స్ ఎనర్జీ. అంటే స్లోలీ ఆన్ ద రొటేషన్, ఆన్ ద రివాల్వ్మెంట్ ఆఫ్ దట్ ఎలక్ట్రాన్, slowly it loses its energy and finally fell into the nucleus, where if electron combined with the proton, nothing but when it is fall into the nucleus, it is nothing but collapse of electron, collapse of atom takes place, which is not happening practically. So means it was we can say it does not explain the stability of atoms with the help of electromagnetic theory. Next one, it does not explain the line spectra of atoms. Here important one, spectra. Spectra means it is a unique property for element. Okay, element unique property is spectra. Just like fingerprint is a unique property for a person, the spectra is a unique property for atoms or elements of a particular substance or particular element. So generally atoms spectra is always line spectra. That means generally line spectra is nothing but other name is atomic spectra. Means the practical thing is the atomic spectra is a line spectra. Line spectra means it is a picture which consists of different lines. When there is a gap is present between the lines, so it is treated as discontinuous spectra. But this is the practical one. So అంటే నార్మల్ గా ఆటమ్స్ కి స్పెక్ట్రా తీస్తే మనకు వచ్చేది లైన్ స్పెక్ట్రా. అంటే లైన్స్ మధ్యలో కంపల్సరీ దేర్ ఇస్ ఎ ప్రెజెన్స్ ఆఫ్ సమ్ గ్యాప్స్ ఉంటాయి. సో గ్యాప్స్ ఉంటాయి కాబట్టి దాన్ని ఏమంటాం, డిస్కంటిన్యూస్ స్పెక్ట్రా అంటాం. దిస్ ఈస్ ద వాట్ ఈస్ ద రియల్లీ హ్యాపెనింగ్. సో బట్ if you follow the Rutherford atomic model, the electron particles slowly loses its energy continuously. Electron continuously energy loss అవుతుంది. If electron loses its energy continuously, the spectrum must be continuous. The spectrum must be continuous. If electron loses its energy continuously, according to Rutherford, the spectrum must be continuous. But practically it is observed that the spectra of atoms is always a discontinuous spectra. Means Rutherford assumptions cannot explain the line spectra of atoms. Okay. Next. Next one, the comparison of next drawback is comparison of atom with the solar system. It also become a drawback in his atomic model. So these are the main drawbacks in the Rutherford atomic model. So what are the best things and what are the merits? So we said that for any theory there is a limitations are compulsory, and it is also another important one. So what are the good things? What are the new things in any theory when compared to the earlier theories? For example, earlier J.J. Thompson model is earlier theory to the Rutherford atomic model. So this is a very better theory when compared to the J.J. Thompson's atomic model. How it is? It explains the position of positive charge. It explains the position of positive charge, that is known as nucleus. I mean, the nucleus part is at first introduced only in this theory. Right, introducing circular path to the electrons. This is also first time. And he also approximately given the size of given the radius of atom is approximately. So he said that the size of nucleus is very small compared to the size of atom. Nothing but for nucleus it approximately given that to 10 to the power of minus 15 meters. For atom is approximately given as 10 to the power of minus 10 meters. So it is in terms of radius. So these are the best assumption given by the Rutherford atomic model. If you compare here, the size of the nucleus is very small when compared to the size of atom. And he also said that most of the space is vacant in it. Mean the total mass of the atom is concentrated at the center point. The total mass, nothing but the total positive charge concentrated at the center point. That is called nucleus. And the nucleus size approximately 10 to the minus 15 meters, and the radius of atom is 10 to the minus 10 meters. If you compare them, the size of atom is approximately 10 to the power 5 times. The size of atom is approximately 10 to the power 5 times when compared to the radius, nothing but size of nucleus. So these are the Rutherford, J.J. Thompson atomic model, Rutherford atomic model, merits and demerits, and alpha scattering experiment. Okay.